Alright, so in this problem, we are trying to solve the differential equation given the initial condition. So the differential equation is dy over dx equals 2xy. The initial condition is y equals 3 when x equals 0. So to solve a differential equation, you're going to integrate. And before we can integrate this differential equation, we've got to get all of my terms that involve y on one side and all the terms that involve x on the other. So to do that, I'm going to multiply both sides by dx and then divide both sides by y. So what it looks like is 1 over y dy equals 2x dx. And now that I have all my y terms on the left and x terms on the right, I can integrate to solve the differential. And any time that I have a variable with a degree of 1 in the denominator, or an expression with a degree of 1 in the denominator, that's a natural log. So if I integrate that, I get natural log of y. And then on the right hand side, the integral of 2x is x squared. And then don't forget about your plus c. Now, what I typically do at this point is I use my initial condition to solve for c before I start solving for y. A lot of times it makes it easier to solve for c when it's in this form. So when I plug in the information I have, natural log of y will become natural log of 3, and I can drop the absolute value bars because 3 is positive. And then x squared would be 0 squared plus c. So c equals natural log of 3. The next thing I'm going to have to do is plug in my information. Okay, so from there what I do is I plug in my c value into my antiderivative to get a particular solution. Once I solve for c, it goes from a general solution to a particular solution. So natural log of y equals x squared plus natural log of 3. Now the final step to solving a differential equation is to isolate y so that it's explicit. That means y is by itself. And the way you do that is you have a natural log of y, and to isolate the y, what you do is you raise both sides as exponents of e. So what it looks like, if I write it out, is e to the natural log of y equals e to the x squared plus natural log of 3. And then what happens when I raise a natural log as an exponent of e, those eliminate. So I have the absolute value of y equals e to the x squared plus natural log of 3. Now at this point, I need to do a little thinking through, and e raised to any power will always be positive. So that means I can drop the absolute value bars. And I now have my particular solution solved explicitly. Now, here's the part where it gets tricky. If this is a multiple choice question, this is not going to be the answer. What typically happens is it's continued to be simplified because I have a natural log up here. And you have to remember that when I add exponents, that's what happens when you multiply like bases. So typically what you are expected to do is expand this exponential to e to the x squared times e to the natural log of 3. And the reason that's expected is because they want you to realize that this would then eliminate and you'd just be left with a constant of 3. So your final answer will be 3 times e to the x squared. Now the reason why this is so important is when we move into exponential growth and decay, you're going to need to start doing that to get some constants that are defined as representing certain parts or important elements to exponential growth and decay. And so it's good habit to get into to simplify it all the way down to this point. All right, and in the next video, I will solve another differential equation.